Guys, we're still on our isosceles trapezoid problems. Sorry, this looks really weird right now. Alright, but anyways, so I'm going to pull up those properties to see if they'll help us with example 5. So example 5 said that RT, which is one of our diagonals of the trapezoid, is equal to 24 units, and QP, this little piece, is equal to 9, and eventually we want to find something about PS. So before I pull up the properties, I'm going to label my picture to see if it will help me to eventually solve. So we know that RT, the whole thing, is 24, which I can kind of label it like this. This kind of includes the whole thing. So this whole thing is 24. Alright, and then on this side, we know that QP is 9. And eventually, we want to find PS. So this is the part we do not know, and we really want to figure it out. Alright, so let's look at these trapezoid properties, and since this problem gave us information about diagonals, maybe we need to look at something that pertains to the diagonals of an isosceles trapezoid. So let's see what we can find. Pull up my nifty property sheet. Alright, so does anything on here tell us something about a diagonal? Because a lot of stuff in here involves diagonals. Look here, you guys. The diagonals are congruent when we have an isosceles trapezoid, which I know this is an isosceles trapezoid because 2 of my legs are congruent. So the diagonals are congruent. Okay, so what that means in my current example, okay, my diagonals are RT and QS. So I know that RT, the measure of RT, equals the length of QS. So that means if RT is 24, that means that QS is also going to be 24. Okay, and that will help us to eventually find our PS. So, we know that the entire diagonal is 24, and we know that a piece of the diagonal is 9. So, how could we find the missing part of our diagonal? Well, let's talk about the segment addition postulate real quickly. Alright, so we know based on the segment addition postulate that an entire segment equals the segments added together that are within it. So that means that QS will break down into segments QP and segments PS. So segment QP added to segment Q or PS will give me the entire diagonal. So we have QS equals QP plus PS. Okay, so if I can fill in all the values that I currently know for any of these, that might help me find PS. So let's see what we can fill in. I'm excited. Alright, so we know over here that QS is 24, so I'm going to fill in that bad boy for QS. Alright, QP we know is 9, so I can fill that bad boy in. And we're trying to find PS, so I'm simply going to bring down PS. I don't know what it is. Alright, you guys, and guess what? We just have to get PS on one side by itself, and then we're done. That's it. Alright, so let's get going. So how do I bring my 9 to the other side? We do subtract the 9. I don't even know why I teach you guys. You guys are so smart. So we're going to subtract the 9 on both sides. Alright, so 9 minus 9 cancels and turns to 0, and 24 minus 9 will give me 15. So, PS, you guys. PS is 15. Board slapper. Threw in some letter humor for you. Alright, so PS is going to be 15. I just cracked myself up. Sorry, guys. Alright, so PS equals 15 units. Since we don't know the units, I can just leave it as 15. Technically, you could write in units if you want, but you don't have to. And guess what, you guys? Bam! This problem is donezo. Holy hot dog.